So let's learn how we can hook up these external sensors to the CPX. So grab your CPX board and remember these copper pads. We used these before for the capacitive sensing activities. Well, now we're going to use them to read external sensors. And so we're going to use A1 through A7. So grab your CPX. We're also going to need some alligator clips. I recommend having a red, yellow, and black. And we're going to hook those up. We're also going to use MakeCode for this. So we've got our CPX board. I've already plugged mine in to my USB, so it's connected to my laptop. And we're going to start to program this. And we're going to take a look at the values off of A1. So before we were using input like buttons, we were using the accelerometer, all of these built-in sensors, the light sensor, the sound sensor, all of these built-in sensors. But now we want to hook up things externally. So we're going to external sensors. So we're going to go in here and we're going to go to, what is it? Pins. So it's in advanced. So if it's hidden for you, click advanced and then pins. And we're going to grab this analog read pin A1. And we're just going to print this value to the console. So I just grabbed the console block. And I'll move this analog read pin over here. And we could just call this A1. All right. And then we'll download that to the CPX. And all right. So you should get something like this. It's really noisy, and that's because we haven't hooked up anything to the sensor. So that's when I want you to grab your alligator clips. So the first clip, the black one, I want you to connect it to ground. So if you look at the CPX, there's a ground pad right here. So it's GND. GND. It's right here. We'll move out of the way. GND, ground. And you're going to use the black cable for that. And then there, over here, there's this 3.3 volts. So for that one, I want you to use the red cable and hook it up. And then finally, we have to hook up A1. So for that, let's see. This is A1. And I'm going to use this yellow cable here. Now we can start to play around immediately. So let's take our yellow cable and our black cable, not the red cable. We don't want to connect the red cable to the black cable. But we can connect the yellow cable to the black and it'll immediately go to 0. All right, so let's do that. Boop. So now in MakeCode, you can see it's going down to 0 or 0 volts. Now, if we connect the yellow cable to the red, which is 3.3, it should go up to 1,023 on the graph, right? And we can go back and forth and back and forth. So here is the black. So that's ground. And here is 3.3 volts here. It goes up to 1,023. We can also just directly tap the 3.3 volt pad. 1,023, back down to ground, which is 0 volts, up to 3.3, and 0 volts, right? So we can go from 0 to 1,023. We could do interesting things with that. We could check to see if something is maybe above 500 or above 1,000. We could trigger some logic or trigger some action. But what if we want to go into a range there? So if you remember when I had that pong paddle, so the pong paddle was built using this potentiometer. we were actually getting a graph that was 0, 1020, 1023. We were getting a graph, and I'm actually going to make this just go to 0 by connecting it so it's not so distracting. I'm going to connect the yellow down to 0. There we go. Maybe actually I'll just do full screen like that. We were getting something like, when I was moving this over, it was going, and then as I changed it, we were going up and down and around like that. So how can we get things like that, a signal in between? Well, what's happening here actually is that we're splitting the voltage. We're splitting the voltage with these variable resistors like these, like this potentiometer. And so another way to think about 0 to 1003 is that this is actually 0 volts down here and 3.3 volts, because remember we hooked it up to 3.3 volts. And so that means that, well, halfway between these things, halfway between is something like what? 1.6 volts, and that is translated to 512. So it's just proportional. And so let's take a look with some actual resistors. So resistors divide voltage, and that's what the CPX reads. So rather than using a variable resistor like this potentiometer, I'm going to use a fixed resistor. And here we have two resistors that I've hooked up. There's two of them here. And they are 330 ohms each. So I'm actually going to attach the black, so ground wire, down to the bottom of this 330 volts. And I'm going to attach the red wire to the top. And I'm going to attach the yellow to the middle. And I want you to think about now what's going to happen. So it's right in the middle. We have now just split the voltage in half. And so we should be looking at something that's right around 512. And in fact, that's what's happening. We've now split the voltage in this little circuit, and that enables us to get halfway between 0 and 1023. And it's dependent simply on the ratio between these two resistors. So if I have a 2K and a 1K, I'm going to split the voltage and it'll drop. It'll be about a third of 1023. So let's take a look at that. So now I have a 2K, a 1K, and it's dropped down to 340 out of 1023. But like I said, it is just the ratio of these resistors that matters. And so before we did this 330, right? And it was half, it was about 512. Well, we could try it with 470 ohm and 470 ohm. Resistance is measured in ohms, which is simply how much resistance it provides, how strong are the resistors, how much does it resist the current. And so here we're back down to 512. So it was the exact same. 470 and 470 is the exact same as 330 and 330. So this isn't that interesting because it's not all that interactive. So really what we want to do is how could we make something like this like little resistor network, how can we make it variable? Well, that's exactly what's happening inside of a potentiometer. It's essentially allowing us to shift the resistance dynamically, and very much like what we had before when we had these fixed resistors where we had the red wire on the top and black on the bottom in the middle. There's also three wipers or three prongs on the variable resistor, this potentiometer, that we can then use to input variable values. So we're actually going to start out by making this manually by hand. And what we need to do is get a piece of paper out. So I've got an ordinary piece of paper, and then I've also got an ordinary pencil. This is just a soft 2HB pencil, and I'm going to start by, let's see if you can see this. I move this a little bit here. I'm going to use 2 pieces of paper so I don't mess up my whiteboard here. So what I'm doing is I'm just going to create my own sort of slide potentiometer using this 2B pencil. So graphite is conductive. So that's going to allow us to create some dynamic input and get insight into how a potentiometer works. So what we're going to do is we're going to hook up ground here, and we're going to hook up 3.3 volts here. So let's try that. Ground and the 3.3 volts here. And now I'm going to use this yellow wire, which is hooked up to A1, and I'm going to slide it. First, I'm going to start by ground. I'll actually touch ground, so it'll go down to 0 right away. And then watch as I move towards 3.3 volts, the voltage gets closer and closer to 3.3 volts. Boop. So there we have. This is a low fidelity potentiometer. We can also make, similarly, a rotary potentiometer, sort of like this, out of everyday materials as well. I am going to play pong using this low fidelity potentiometer. So I'm going to pause, switch over to pong, and show you how this works. All right, now I've got my potentiometer mouse code running so we can play pong with our low-fi potentiometer. So let me switch so just you can see the graph again. Boop. As I move it closer to 3.3 volts, now I'm touching 3.3 volts, down. So it's just proportional to how far I am from ground and how close I am to 3.3 volts. So now let's open up Pong. And I have this program so that when I switch the CPX over to the right, it'll turn it into a mouse. So let's play this again. I hope I'm playing it on easy mode. Here we go. So now I'm playing Pong with this low-fi potentiometer. See, as I move this back and forth, I'm able to control the paddle. Whoa, whoa, whoa. I'm doing pretty well, actually. Awesome. Can I win? There we go. That's just using the lo-fi potentiometer as input to our computer, which is pretty awesome. So now let's move on and take a look at using an actual potentiometer, and then we can think about how it's built.